On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to talk about when the limit does not exist. So sometimes as x approaches some value c in some function, that L that we've been talking about, that L may not exist. There's three cases we want to look at here, and we're going to look at all three of them in this video. But the three cases are when the function shoots off to positive or negative infinity, and it's important to say that's what's happening as we get close to this value c. Or the function approaches two different y values as we get close to our x value of c. We're going to see that example visually in a second as well. And then last but not least, we have oscillation. We'll see that at the very end of this tutorial. So that first case here, the function shoots off to positive or negative infinity. Look at this example here. We want the limit as x approaches 4 of 1 over x minus 4, and I'm already telling you that this does not exist because we're trying to get close to this x value of 4 on our curve. So notice what happens here. I got these little dots, and as I get close to 4, notice these dots start to shoot down forever and ever and ever. It's shooting off to negative infinity. Very similar, coming in from the right-hand side, as we get close to this x value of 4, these y values start to go up, 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 forever and ever and ever, so it's shooting off to positive infinity. Yeah, true, we are approaching two different y values. One's going off to negative infinity, one's going off to positive infinity, but the idea here is this. We're not approaching a set number. We have to be approaching a specific number for the limit to exist. And in this case, since we're shooting off to negative infinity, and over here we're shooting off to positive infinity, the limit does not exist. The second case, the function approaches two different y values as we get close to our x value of c. The example here is a piecewise function, and I have it graphed over here. We have some line 2x plus 2 for values of x that are less than or equal to 1. Now, we'll look at graphing these later, but for now I just want you to see the idea. So, on this red line, as we get close to 1, we're trying to find the limit as x approaches 1. So over here, as we get close to 1, this x value of 1 right here, our y value is approaching 4. This is referred to as a left-handed limit or left side limit. However, on the blue curve, that's this parabola, x squared minus 5x minus 1, and we're only graphing this for values of x that are bigger than 1. So as we get close to this x value of 1 on the blue curve, as we get closer and closer and closer to an x value of 1, it looks like our limit is going to be negative 5. But notice we are approaching two different y values. Up here is 4, down here is negative 5. Therefore, the limit does not exist because our second case for a limit to not exist is if we approach two different y values as we get close to our particular x value, in this case 1. Our third case, oscillation. And here's one example. There are other examples of oscillating functions, but let's find the limit as x approaches 0 of the sine of 1 over x. It does not exist. Let me show you what oscillation looks like. So here we are in Desmos, and this is the function y equals sine of 1 over x, and we're trying to find the limit as x approaches 0. So what I'm going to do here is I'm going to zoom in, and I'm trying to get close to this x value of 0, but notice what happens. This curve starts to go crazy. It's oscillating, and no matter how far we go in, it starts to get trippy looking, but it's oscillating. We are not approaching a specific y value here. When you have oscillating functions, I can keep zooming in forever and ever and ever, and all you're going to see eventually is just a big green rectangle, but really, this function is oscillating so fast, it's not really a rectangle, but these lines are really close together. We're not approaching a specific y value, and we had this crazy oscillation stuff going on. This is your third case of when a limit does not exist. So there you have it, 3 examples of when a limit may not exist. The 3 cases here were when we shoot off to positive or negative infinity, we approach two different y values as we get close to our particular x value, or we have the oscillating function like we saw over in Desmos. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.